Starting with version 12.131, a professional license of ease can be called from other applications using the SendMessage command in the Windows operating system. So ease will respond to a SendMessage command with the format that is shown here. And we've already seen this in some other videos for Excel and MATLAB and Python, and the format's exactly the same. You have result equals SendMessage, and then there's 4 arguments. The first argument is the window handle of an open ease program. The second parameter, this WM run ease, is the integer message type that ease is programmed to recognize, and it must be set to 32777. And then the third parameter, em command, is the integer that specifies what action you'd like ease to take, and there's some choices that are listed down here below. The first 3 options correspond to manipulating a log file that logs the commands that are executed during the process, which is useful for debugging. That log file itself is maintained in whatever folder you have ease installed in, and it's called ease call from app.log. And so you can delete the log file, you can turn off logging, or if you want to, you can create the log file if it doesn't already exist, and then start logging to that file. And then these last 2 options are the important ones. 10 em solve here says solve the file, so it's basically equivalent to hitting solve in the ease program. And then 20 em run macro tab runs a macro in an open ease application. And the macro that's run is the one in tab number corresponding to this last parameter extra. And if you're not using em run macro tab, then that last parameter extra should be set to 0. So the Windows handle for ease can be found in a few different ways, and it seems like generally getting the Windows handle is the trickiest part of the process. So if you watched the videos on interacting with ease from within Excel, you saw that we could use a call to the FindWindow command, giving it the parameter TES_D, and it would go off and find an open ease file that way. But that didn't work within MATLAB. So if you watch that video about interacting with ease from MATLAB, you saw that we ended up having to use the getProcessesByName command from within the system.diagnostics.processes net class. And it turns out that neither of these methods work within LabView, so we're going to actually have to use the EnumWindows command that is within the Win32 GUI library, and we'll execute that command from within Python. But otherwise, the approach used from within LabView is exactly the same as what we've seen previously to communicate with ease from other programs. Right, so we're going to keep ease open and ready to respond to commands issued by the calling program, and we're going to pass data to and from ease using data files, and the whole process then becomes relatively fast because ease never has to restart before it executes a command. Alright, so here let's go ahead and build just a very simple LabView program that does exactly what we did for Excel and also for MATLAB, which is it just uses ease to calculate a thermodynamic property at a specific state, so a specific fluid and temperature and pressure. So I'm going to start LabView and create a new VI, which I'll just call LabView example. And I'm going to save that VI in a folder also called LabView example. So I'm going to want to put a couple other files into that same folder. So the first one is GetEESHandle.py, and that's a Python program. And this is the Python code that runs the EnumWindows command, which is going to be used again to find that handle of an open ease window. So if we want to run this, we're going to have to make sure we have Python installed, and we're also going to have to make sure that we have the Win32 GUI library in Python installed. If you look at the code, you can see kind of how it works. Right, it's going to go through all of the open windows, looking for one named TEES_D, and then when it finds that window, it's going to print the handle that it found to the standard output. Right, so if we're running it from command line, the standard output would be the screen, but we're going to be running it from within LabView, so the standard output will be a string coming from the VI. All right, I'm also going to put the EES code calculate v.EES into the directory, and I'll just go ahead and start this. This is the same EES code that we've used when we ran from within Excel, or we ran from within MATLAB in these previous videos, and all it does is it reads in the fluid temperature and pressure from a file called State.dat. In this case, it'll be in the LabView example folder, and then it calculates the specific volume using the internal function volume from within EES, and then it's going to write the resulting value of specific volume to a file called v.dat in that same folder. Alright, so let's go back to the VI, and in the block diagram of the VI, let's start by just adding some controls that will allow us to enter the fluid name, the pressure, and the temperature. And we'll label each one and put units, stuff like that. Next, we're going to have to do some things sequentially, so we're going to have to write the file State.dat and then send the message to EES to run, and then finally read the file v.dat. So let's use a flat sequence structure with 3 frames to do this, and in the first frame, that's going to be where we write the file. So to do this, the first thing we have to do is build the string that we want to write to the file. So to do that, I'll have to append a single quote to either side of the name of the refrigerant, and then add a space, and then I'll follow that with the temperature, but the temperature of course has to be turned into a string, a fractional string, and then another space, and then the pressure also converted into a string. So that's the string we want to write to the file, and then this string will be fed to a write text file VI, and then we'll go ahead and write this to the LabView example folder as the file State.dat. So at this point, I should be able to run my VI, and I can go to that folder and check and make sure that the file State.dat is present in the folder. And if I open it up, it should look okay. It should have a string for the fluid. Strings in EES are surrounded by single quotes, so that looks good. And then 2 numbers corresponding to the temperature and then the pressure. Alright, so once I'm satisfied that I'm writing the file State.dat, I can move on to the next frame. And this is the frame where we're actually going to run the Python code that will provide us with the Windows handle for the Open EES program. So this is done by running that Python code from within a system exec VI, and that's just going to take the command line command that you'd like to run. In this case, it's going to be the word Python followed by the name of the Python code that we want to run, and the Windows handle is then provided as the standard output from this VI. Right? And in this case, it's going to be a string, which we're going to have to convert into an integer using the scan from string VI, and we'll add a format string here, %u, that will force it to be an unsigned integer, which is the kind of integer required for the SendMessage command. So that handle now is one of several inputs that we're going to have to send to the SendMessage command. So we're going to use the SendMessage W command, which is the Unicode version of the SendMessage command. And it lives within the user32.dll library, which we will access from the call library function VI. So we're going to want to use user32.dll as the library, and we'll select the right command here, and then we're going to call it as a Windows API call. And then if we go to the next dialog here, this is where we specify the parameters. So the parameters include an output, which is that result code, and that has to be set to a signed 64-bit integer. And then I got to add 4 inputs. And the first input is that Windows handle, so that's an unsigned 64-bit integer. The second input is that message code that EES is programmed to respond to. So this is an unsigned 32-bit integer that will eventually set to be 32777. The third is the command that we want to send, which for us is going to be the solve command, or the integer 10 eventually. And that has to be an unsigned 64-bit integer. And then the last input parameter is another unsigned 64-bit integer, which is that extra integer, which we're not going to use here, but we still have to send it basically 0. So let's go ahead then and wire the Windows handle to the first input, and then in sequence 32777, 10, and 0 to the other inputs. And let's go ahead and display. So we'll add an indicator for both the Windows handle and the output, the result, for troubleshooting purposes, so we can see that everything's working okay. So if I run now, what I should see is that the EES code solves, and I should also see that a file v.dat has been created. And if I open that file v.dat, that should contain the specific volume that was calculated from within EES. So let's go on then to the last panel, this third panel, which is where we're going to read the data file v.dat. So this is pretty easy. We'll just use the read text file vi. We'll give it a format string %f to indicate that we're reading a floating point number, and then we'll go ahead and just display this as an indicator on the main panel. And so right now I should have a program that runs. So if I enter the fluid and the temperature and the pressure and I hit run, you should see that EES solves, and I get the specific volume for that fluid and state right here in this indicator. And you can do all kinds of things with this, obviously, right? This is pretty trivial what I'm doing here, but you can see how as you're taking data now, you can reduce that data in EES if you want to have access to some of the capabilities of EES for that. You could, if you wanted to, take the data, plot it on a TS diagram or something like that, and then save the TS diagram and have that be loaded into your LabView code. You can turn this whole thing into a sub VI that just gets called, so it's very easy to execute this whenever you want to access some capability of EES.